electric field in vector form. Now we know that electric field formula which we have obtained earlier class, kq by r square. We have discussed like this. If q is the charge like this, then we have find that at this certain distance r, we have find that electric field will be kq by r square in our previous lecture. Okay. Now when we have to find the electric field in vector form, how we will find? We know that if charge is positive, electric field will be in this direction, outward. Let us suppose outward unit vector is r cap, like this, r cap. To represent this electric field in vector form, we have to multiply this magnitude with a unit vector r cap. So in vector form, we can write that electric field E vector is into r cap, like this. And we also know that k q by r square, and we know that unit vector is equal to r vector by r vector magnitude. You know, from class 11th vector chapter, we can write like this: r vector by r, the vector and the magnitude of that vector. So we will replace this r cap by this, and it will be represented by r vector by r. That means we will obtain E is equal to kq by rq into r vector, like this. This is the electric field in vector form. Any problem till now? We will take one question also here. Okay. Now let me take one question. It will clear a concept also. Any problem in vector? Now let me take one question. Okay, then you will get clear. Now one question. Let me take one question. One question is that, suppose it is given that we are having a x-y axis like this, x-axis, y-axis, at a point which is x, y, and z, like this given, and at a point A, there is a charge. Coordinates of a point A is 2, y minus 1, like this 1, and z minus 2, like this, and charge is 4 coulomb. Charge is Q is equal to 4 coulomb. We have to find electric field at a point suppose 1, 0, and 1. At this point, we have to find the electric field. Question is that only. What is given? A point is given having coordinate 2, plus 1, and minus 2, and a charge is 4 coulomb. And we have to ask that what will be the electric field at this point. How we will proceed? Okay. Any idea how we will proceed? We will use the same formula. What formula is? E is equal to kq by rq into r vector, like this. What we have to do? K we know, q is given, r vector and r. We have to find only r. This. How we will find r? So to find r, we know there are 2 points, A, and the point is given, second point is given this. Let us suppose this point is, this coordinate is B. How to find this point? We know that r vector, first vector is A. We know that if 2 points is given, one is A and second is B, and we have to find this vector, r vector. How we will find? We know that r is equal to position vector of B minus position vector of A. We know in class 11th, from class 11th only. So to find this r, what we will do? We will find the position vector of B. For position of vector of B, we can write like this: x coordinate 1, we will write I cap. Y coordinate 0, when it will get vanished. In Z coordinate, it is 1, so J cap, minus unit vector of A point. A point is this, We can write it like this. We can write like this. R vector of A point will be what? We can write in vector form like this. 2 I cap plus 1 into j cap minus 2 into k cap. We will write like this. RA here 2 I cap plus j cap minus 2k cap. We will get here what? We will get it. We will subtract this. We will get minus I cap plus 2j cap and like this. I think some calculation mistake occurred. Minus 2 here. I think this will be minus 1 minus j cap. This will be R vector. Any problem in finding this R vector? Only trick is to find R vector only. Any problem, Nandini? Any problem, anyone? Any problem to find this R vector? How to find this R vector? Any problem? Okay, good, good. Now, if we have find this R vector, then we can find that what will be its magnitude? That is R. It will be under root x coordinate. That will be x coefficient of this I cap minus 1 whole square, j minus 1 whole square, and k 2 whole square. We will get 1 1 1 4 and here 6. Just put here 6 and just put R vector here. You will get the electric field in vector form at this point, B point. We can similarly put the values 9 to 10 power 9 and 4 coulomb, and that all those values R vector here and R cap and value of magnitude we have got here root 6 whole cube. Only this will be our answer. Okay. Okay. Now let us move further. I think by tomorrow we will be completing the chapter, and on Monday, sir, I got root 11. Root 11 answer. R vector or total answer? Let me check. Let me check. Let me check. Maybe calculation mistake. Maybe some calculation mistake. Maybe some calculation mistake. I cap plus j cap minus 2 I cap plus j cap minus 2 k cap, and here we subtract minus I cap. Okay. I think j is getting vanished. J is getting vanished. Oh, mistake. You see here, it is not j cap, it is k cap. It is k cap, na? I cap plus 0 j cap plus k cap here like this, and we are writing here this is RB. Here what we get here, we can replace like this. It will be I think minus I cap and minus j cap, and it will be also plus 3k cap, and similarly good calculation mistake. Yes, it will root 11 only. Okay, fine. You can put here root 11. Okay. Nah, that's why I tell you, please check the calculation mistake. I usually make some calculation mistake. Okay, good. Now let's move further. Okay, na? Now let us move further. By tomorrow we will be ending the chapter, and from in Monday class will be very important for us. I will be discussing NEET previous year paper sum and some good questions also from different books that will be very much beneficial for your upcoming NEET exam. So please be careful for Monday class. It is very much important for you. Now here we are discussing that what is electric potential energy. Though we are not concerned with definition, what is the definition, but in brief I am discussing here what is the definition. Just it is telling that, so suppose we know that electric field has some reason where it can show its effect, and that reason is called as electric field of this source charge. To find this electric field of source charge, what we do, we bring some electric field here. some charge here at a point R. So electric potential energy is defined as, suppose from point infinity where potential energy is 0, at this point if we bring some charge, that is test charge Q, positive test charge, bring this charge from infinity to a point within electric field, to bringing this charge from infinity to a point within electric field, the work done is called as U, by definition like this. So here we are concerned not about definition, just a concept to bring in from infinity to a point within electric field. And the work done, when we calculate by using our integration, what we get is that U is equal to K, usually we write minus K, Q by R. And this is electric potential energy. Okay. Q by R. If suppose we have Q1, Q2 point, distance R, U will be K, Q1, Q2 by R. This will be the electric potential for a 2-point system. Okay. By this way, we have found the electric potential energy. Now, remember one thing. This is for a system of charge having 2 charges. If there are number of charges, what we will do? Suppose Q1, Q2, Q3, Q4 like this. And we have to find potential energy at any point. What we will do? Since we know that it is a scalar quantity, we know it is scalar quantity. Since it is scalar quantity, it doesn't need any special addition rule. It just adds up like a scalar. So to find the electric potential energy total of the system, it will be U1 plus U2 plus U3. Just adds all the electric potential energy of each charges. We will get the electric potential energy of system and so on. This is called superposition rule or theorem. By using superposition theorem, we will use it further, and we will solve some question also.